students with us today. This session has been specially organized to help you gain valuable insights beyond the classroom and explore how emerging technologies are shaping the future. Today's session on the topic Building Gen AI Solutions with LLMs and MCP is designed especially with you in mind to give you practical insights, inspire new thinking, and help you grow both academically and personally. We are truly honored to have Mr. Narendra Singh Bisht with us today. He is a seasoned data scientist at Publicis Sapient with expertise in agents, cloud, generative AI, MLOps, and NLP. With an MTech in AI and 5x Azure certifications, he brings a wealth of knowledge and industry experience that will surely inspire and guide you. I'm happy to inform you that he is a second rank holder with a silver medal in MTech Artificial Intelligence from Amrita Vishwavidyapeetham. From starting his journey as an associate in network records to rising through the ranks over 8 impactful years, he now serves as a senior associate in data science at Publicize Sapient, an inspiring example of dedication, growth, and passion for continuous learning. On behalf of Amrita Online CS department, I am delighted to welcome you, sir, to this exciting webinar. We are truly honored to have you here, inspired and engaged with our students. It's a pleasure to have such a diverse and engaged group of participants joining us from various locations. I extend my warm welcome to all the enthusiastic students who have joined here today to fruitfully grab the knowledge. We encourage you to participate actively, ask questions, share your thoughts, and make the most of this interactive platform. Thank you all once again for joining us. Let's have an engaging and fruitful session ahead.
Thanks for the warm welcome. And although today's session is about generative AI, and as you know, this is not something that used to be there, let's say 5 years back, right? So I would be telling you little about my experience with AI so far. So my career, like I have experience of close to 8 years, and it's equally split into 4 into 4. So the first years were into full stack development, and the second half, like 4 years in four different types of AI, I would say. I have worked in four companies in the AI teams, and in each company, AI meant something different. So during MTech, I did my 1 year internship at ABB. There, the focus was on anomaly detection. It was mostly sensor data, and the goal was to have a federated learning based model trained using all the data sensor data that we have, so that anomalies can be detected in advance for heavy equipments that ABB was managing. So we used a simple auto encoder architecture at that time. And next, I worked at L&T. There, the focus was on computer vision. So since L&T works with a lot of government clients, they had a lot of data available, and we were training computer vision models, which were being used for automatic number plate detection and the challenge you would be seeing these days. And so the idea their AI meant mostly computer vision, at least in my team. Next, I worked at Tidence. There, they were using AI to forecast demand for CPG clients. Again, a different variation. And now at Publicis Sapient, here the focus is primarily on Gen AI. But one thing that was common in all four organizations was the MLOps. So once we are done with the data science part of it, to make it available to enterprise customers, we need to have a scalable solution in place. So that's where, although the buzz is all around Gen AI and agents, a lot of my time is also dedicated to upskilling myself in cloud and deployment strategies using Kubernetes, because that does play a role in my day-to-day activities. Okay, so now starting with the presentation. I hope my screen is visible in full screen mode, right?
Yes, sir.
Okay. So see, I have four key agendas for today's presentation. First, we will have a quick look what are LLMs. Then we will move on to MCP. I'm hoping to spend 30 minutes at least on the demo part of it, in which we will see how the architecture for the agentic mode in VS Code looks like. And we will try to build an MCP application from scratch, all using the agent, no manual coding. Okay. And finally, I'm hoping to have the last 10 minutes for Q&A, since it's an engaging and upcoming field with a lot of things happening every single day. I'll be happy to answer any questions you guys might have. Okay. So I think large language model LLMs are the building block, basic building block for most of the cool Gen AI applications you see these days. If you have seen any of these icons in your day-to-day lives, Meta AI, Mistral, Claude, Grok, Perplexity, ChatGPT, Copilot, Gemini, and that means you are already familiar with how convenient and easy it is to get started with Gen AI. Most of the major providers have their own apps using which you can interact with a large language model. Most of the times, you will even have an option to choose which LLM you want to interact with. Most of these providers come up with newer models, and the moment they come up with a newer model, most of the times the previous model is made available freely on these apps to interact with. Of course, there is some limit. It's not like you can use it commercially, but yeah, for normal day-to-day activities, whatever limit they provide is more than enough. Okay. And if you look closely in this, you would see apart from an LLM, now we also have additional things available here. Okay. So usually when you interact with an LLM, all you do is you type a prompt. A question is a prompt. But now, first you would have heard about prompt engineering, right? That was about how well you can write a prompt to get the best out of a given LLM. Now we have a new term, context engineering, that is more popular nowadays, and that's all about providing the LLM the right context that necessarily need not be just the prompt. LLM can have access to multiple tools, for example, and also it can have access to multiple modalities. Apart from your prompt, you can attach some images, or even you could have some video or audio inputs that would give a better context to the LLM to give you the best possible response. Okay. And additionally, in Gemini, for example, now you have an option to give your live camera feed to the LLM, and you can even simply ask it, okay, what do you see and what do you think about it? Okay. Again, it's all very cool. For an end user, it's very easy to use. Now let's see what goes behind this. Okay, so now if we talk about the history of large language models, there is not much history to it, to be honest, for LLMs in particular. See, AI is an umbrella. Like we have machine learning, a sub part in it, and then we have deep learning, and then we have Gen AI. So if we focus only on the large language models, the buzz started in 2022 when ChatGPT first made an appearance. Since it was an easy to use UI interface, even a common man was able to interact with the LLM and see the magic. At the backend, they were powered by GPT models, which have been upgraded over the last couple of years. The most recent one at the moment is GPT 4.5, but that evaluation, all this evolution happened in a matter of just 2 years. So that's quite astonishing. So the evolution happened both for proprietary models and open models. So in case of proprietary models, the only way to access them is through paid APIs. For testing, you do have some of these APIs available for free, but for enterprise use, there is always a cost that needs to be paid. So in competition, some organization decided to go with open models. So these are the models which you can self-host, and use it for free afterwards. Okay, so some of the popular open source model would be Llama, Quen, Mistral. Same with some of the proprietary and popular models are GPT, Claude, Gemini. Okay, and one more thing to notice here is most of these models come with a different set of parameter options as well. For example, Llama is available with in a 7 billion, 13 billion, 33 billion, and the newer models of Llama, some of them are even, some of these LLMs are now reached that stage where even a 1 billion model is able to compete with some of these bigger models, which is pretty cool. So although LLMs are popular at the moment, but agentic AI on the rise. Recently, there was a paper that says SLM are the future of agentic AI, which will definitely be the case. Today, I will show you one. I think a 2 billion model that's able to do multimodal ingestion and understanding. So quite cool. Okay. So although we are used to asking a question to the LLM and expecting it that it will give us the complete answer, but in order to understand how it works, one basic concept that we need to understand is embeddings. So anytime you input something uh, that is not understood as it is, it has to be converted into some form of vector representation so that it can be or some form, in this case tokens, so that it can be understood by the model. Okay, so now in order to embed it, there are multiple options. So the entire document can be embedded at a single embedding, that would be document embeddings. You can split the content into sentences, that would be your sentence embedding. You can split the sentence by spaces, that would give you the word embeddings. And you can even further split it down to a smaller unit, that is tokens. Now tokens is what is used when the model is trained. Same way, when you ask a query, the same approach is followed. The question will be converted into an embedding before the model can understand what the question is. Okay, and that embedding can be used for other purposes as well. But at a high level, yeah, this is the language that model understands, both at the time of training and at the time of inference. Okay. Now, one more thing to notice here is, although we see a complete answer for every question we ask, but internally, the large language models are not generating that whole paragraph at a time. And and the way we see it in a UI, like one sentence coming followed by another, sometimes word by word. So that's not just for effect. Actually, the LLM is generating it word by word. So for example, if the LLM has to generate the word, let's say this is the question, tell me something about llamas. So the initial number of tokens would be 6 here. And in order to generate an answer, the LLM will first have access to these 6 tokens, using which it will generate a new token llamas. And in order to predict R, it will have again access to the last 7 tokens. Once R is predicted, it will have access to the full 8 tokens to predict the next word domesticated. So two things to note here: it generates the output one token at a time, and now since the modern LLMs have a huge context length, most of the times whatever you have asked it, that plus whatever has been already generated, both of them will be part of the context, so that the output can have the best possible, the model can give you the best possible response. So an advanced version of this would be if you're having a chat with the LLM. In that case, it's possible that the entire chat is used as a context to give answer to your most recent question as well. Okay, so the context length keeps increasing. And every time you ask a question, if you're sending back all the previous tokens as context, the LLM providers charge you as well, because the pricing is per token. Okay, so it's very, we have to see how much context we need to provide to get the best possible response in a chat based application. Otherwise the pricing will be too high. Okay, now one thing you would have heard very often is RAG. So normally if you ask a model a question, it would only know the information on which it was trained. Most of these models have some cutoff date for training. And if you ask them a question more about a more recent event, they would probably either won't tell you or they will hallucinate and give you a wrong answer. So an easy way to fix was to come up with RAG. RAG is retrieval augmented generation. So there are two parts to RAG. One is at the time of setup, what we do is if we want the LLM to ground its response in some knowledge base, that knowledge base could be all the documents related to an enterprise or a university, for example. So in the pre-processing stage, all those documents will be converted into chunks, and we would be next creating embeddings for all those documents or for all those chunks, and those chunks will be stored in a vector database. So now vector database is a special kind of database which allows you to search for records using an embedding. So when a user asks a question, that question will further be converted into an embedding, and that embedding would be compared with all the stored embeddings in the vector database using a similarity search. So if the similarity search finds some matching information in the vector database, that information will be re-ranked to make it more relevant to the questions. Here come even the re-ranker models, which allow us to re-rank the responses retrieved from a vector database um, in order of more relevance to the question asked. And then together with the question that was asked, even the retrieved chunks from the vector database will be passed on to the large language model, which could have a pre-defined prompt as well. So all of this will together become the context for the large language model. And this is what context engineering is all about. And that will help the LLM ground its response in the retrieved information. Now, even if you ask it something which it was not trained on, it would still be able to ground its response in the retrieved information and give you a valid response. So this is vanilla RAG, like the first version of it, and most enterprises have some form of RAG available to help their employees search to the enterprise knowledge base. So this could be about just the policies or even past interactions with the clients. If you want to know, okay, in the past, what kind of mistakes were made for this particular client. So even that kind of information can be retrieved easily. Okay, this will come in handy when we go through the demo, this understanding. Okay, so now coming to MCP. Okay, so this is not new, to be honest. This was introduced by Anthropic. Anthropic is again one of the popular providers for LLMs. They have the Claude, Opus, and other Claude series of models, very good models. And so this MCP is Model Context Protocol, and see, context is very important, that word itself. So this is an open protocol that standardizes how LLMs access tools, data, and prompts from external sources, simplifying how new content is integrated into AI applications. So one way we saw RAG. So RAG was getting that relevant context from VectorDB, but now this will standardize how you get it from not just one vector database. There could be 20 vector databases out there. And in order to get the relevant context from each one of them, you won't be expected to write a code from scratch. And all that would be thanks to MCP. We will see actually in the demo how just using MCP, I will be able to connect to 4 vector DBs, at least 2 for it now. So In MCP, there is a concept of MCP client and MCP server. An MCP client is hosted inside an MCP host. So it's a client server architecture where the server will expose some tools and the client will be able to use those tools to help LLM get a better context. And the MCP server can be an independent process, or it can also be initiated by the client as a sub process. So both options are available. Okay. So as I said, it's a client server architecture. The host is allowed to have multiple MCP clients. Each one of them can connect to an MCP server. But the cool thing is they all will be connected via the same MCP protocol. So that would allow this part to be very simple. Otherwise, if I'm writing an application, which is my host, and if I want to interact with 10 vector databases or 10 different tools, it's possible that I have to write custom code for each one of them. With MCP, I would know uh, how each one of them is exposed in a similar fashion so that I can communicate to all of them in the same way. Internally, MCP server will take care of managing that complexity for us so that we need not worry about it. So mostly MCP servers are published by the owners of that database. For example, Milvus, right? Milvus is a vector database. So the MCP server for Milvus will be published by that company itself. Same goes for PostgreSQL, Redis, MongoDB, all of them. Okay. So hosts are LLM applications that want to access data through MCP. It could be Claude Desktop. This was the original one. Since Anthropic released MCP, and they are the owners of Claude series of models, they also have a UI called Claude Desktops, and they had shown how you can integrate multiple MCP servers in this UI. Now even IDEs like VS Code allow you to do it. In demo today, we will see how VS Code allows us to do it. But ultimately, all this was done so that AI agents can access all these tools easily. So this is one of the main use case. Okay, servers are independent programs. So you can write it in Python, for example. Most of the MCP servers nowadays are being written in Python using fast MCP. It's like inspired by fast API. MCP client again, most of them, it depends. You can write it in other programming languages as well, but Python is the most common one. Okay. So in summary, MCP server will be exposing tools, resources, and some prompt templates. An MCP client will be able to invoke those tools, query for the resources, and use the prompts. Okay. So the plan for demo is we will see how the agent mode within the VS Code works. And before we see it in action, let's discuss the architecture. Okay. So if you look at the right side, you have a large language model. Okay. But in order to truly deliver a useful feature, it can't be just an LLM, right? You need a whole ecosystem around it. And this is the architecture for the agent mode in VS Code. It's a good architecture which can be used in other applications as well. Okay, so in most applications, instead of user, you could have some other component which needs some action to be performed. So that action will be described as a prompt. Now, once agent receives the prompt, it needs to take a call whether or not or which tool to call. So it has access to all the tools. Now, whatever you see in blue color here, it is the custom tools created by VS Code and made available to the agent that operates in the agent mode. And whatever you see in green color, these are some of the additional tools exposed by custom MCP servers. For example, Perplexity MCP server, it will have some tools. GitHub MCP server, it will provide another set of tools. Same goes for, there are many extensions in VS Code. Each one of them are also able to contribute to the set of tools available to the agent. So now LLM is not alone. It has a lot of tools available to actually do some task within your workspace. Okay. So an agent would decide what prompt, context, and tool description it should make available to the LLM, and the result or the decision to call the tool with arguments will be sent back to the agent. And once agent gets to know, okay, LLM has decided this tool needs to run. See, tool are, you can think of it as a function where you have, if you have to call some for arguments A and B, somebody has to tell you what is that A and B. So that A and B will be decided by the large language model. Agent, since it has access to the tool, it will call that function, pass those arguments, and get that value. Okay, and once it gets back the response, it can again ask LLM whether this is sufficient. If that is sufficient, it can return the response back to the user. One more thing to notice here is, for actually running any tool, agent will always seek a confirmation from the user. So the user will always be in control. Okay, now I will do something. Anyone has any questions so far before we go to the demo? Okay, so let me show you something. Okay, there's a poll there. Okay, so see, this is the documentation to create an MCP server using fast MCP. Okay, this is one of the popular SDKs that is being used to create MCP servers. And again, this is just like if you have used fast API to create REST APIs, then the syntax would be very familiar. Actually, that was the original motivation behind calling it fast MCP, so that fast API users find it very familiar and use it readily. Okay, so normally, let's say I have to create a fast MCP server. Okay, I have no clue how it has to be done. I'm a new, like completely new person. But now with agents, it's possible to do development actually without knowing what to do. Okay, if you already know stuff, then it makes you awesome. Okay, but if you're a beginner and you just want to experiment, even in that case, it's very useful. Okay, so all I will do is I will just copy this URL, and this has information how to create a fast API server, how to test it. Okay, but I will not read any of it. I will just copy the URL. I will go to VS Code. I will open Copilot. Okay. So right now, if you see on the left, there is nothing there, right? It's just an empty folder opened in VS Code. On the right, you have GitHub Copilot. Okay. And at the bottom, you can see out of the available modes, I have opted for agent mode. And I will go with the best model available at the moment, and that's GPT 4.1. And I will ask it to create it for me. You follow these instructions. For me, no prompt engineering. I will just keep it very simple. Okay, again, you see the word context, very important. And one more thing I will do is I will ensure that too many tools are not active. So we saw, right, the ones in blue, the tools provided by VS Code itself. So this built-in tools are those blue tools, and MCP server. This is an external MCP server I have integrated. So these are the green ones. I will just disable them for now because for first part of the demo we don't need them. Also, there is an upper limit of 128 tools that can be enabled anytime. If you provide more tools than that, then the agent will be confused which tool to run. Okay, so even let me disable load testing. Even a show room is needed. Okay, so let's go ahead and see for every external tool or every tool it will seek permission. Okay, so it wants to read this page so that it can figure it out. I will allow it. Now it wants to configure a Python environment because as a beginner I did not create a Python environment, but that's a good practice. We should never install anything in the base Python, so I will allow it. So here it needs a manual intervention that I will do. I'm creating a .vn virtual environment within my project itself. I will go with 3.12. It wants to install fast MCP. I will allow it. Okay, see it wrote, it wrote, understood and it wrote code. Server is ready, client is ready. Now it wants to actually run it. Okay, so it's wrote the code and now it's just seeking permission to run it. Let's see. Okay, so it actually ran it and there was a result. Okay, but it's not clear to me. I will just ask it to run it again. How can I be sure that this MCP server works? So it is telling me in one terminal start the server and in one terminal start the client. So if the server is running and the client calls it, it will get some response. Okay. So even this I will ask it to do. Okay. So since again it's running a tool, it will look for permission. In one terminal it started the server. Okay, and in another terminal it wants to start the client. Okay. So if you see here that MCP server is running and in another terminal it actually sent a request to that and it got a response. Okay, again this is not very clear because it's a terminal. I want to see some UI, so we'll ask it to create a UI. So we'll use fast API for that. Again, in order to create a fast API application, it needs to install some packages. It's asking permission for that. Okay, it has written the code. If you see, there's a third file here, fast API agent. Now it's requesting permission to run it. Okay. Okay, so it not just, it even opened the web page. Okay. knowledge, just try it. So curl request was sent. Okay. There was some error, which is good because we can ask it to fix that as well. After this, we look at the code also. Okay, so it understood the problem, updated the code directly. For now, I will trust it, and it wants to restart the fast API server. Okay, now that port is already used. So one way is we can run it ourselves using a different port, but even let's allow it to do it. So it is asking us to kill the process and rerun, but we will let it do it. Okay. Okay. So let's open the UI ourselves this time. Let's try it one more time. It fixed it, and now we have a fast API server with one endpoint. This is acting as an MCP client, which is able to call the fast API or MCP server. Let me close the necessary terminals. Yeah, so which is able to use a tool exposed by this MCP server. So how cool was that, right? I did not code, but I have an MCP server, an MCP client, and a wrapper fast API application, which is using that client to connect to the server. Again, see, if you know how it works, then it is very cool. Actually, it's like really like increases your productivity. And I mostly use this mode to write test cases. I think most developers will agree with that. Developing something is very cool, but writing unit test cases is not something most developers enjoy. So that's where this kind of free assistant is a lifesaver. Saves a lot of time, and even the edge cases which sometimes we can miss, it won't miss. Okay, it's good to know this power, but I would not recommend using it for every task. That way you will not learn. But this is pretty cool actually. So anyone has any questions about this? Yeah. What we did or how we did it? Okay, so let me close this. So if you look closely, how the server was created, okay. From this SDK, we imported a class. We created an object of that class. You could have written anything here. And then using that object, we are able to create a tool using this decorator. And that decorator is making this normal function an MCP tool. And ultimately, we are just running the MCP server using the same object and the run method. Okay. So this was how an MCP server is created. And if you look closely at the client, So again, this client is imported from the same SDK fast MCP from which you had imported this class. And but instead of creating a server, this time you are using an async method to call that tool. The name of the tool is greet, right? So you are calling that tool and you are passing that required argument. And since it's an async function, you need to use an await, and you cannot put await in a normal Python function. So this has to be async, and you can't call an async function directly in a script. So you need to use async io.run. Okay. So this was how the MCP part of it is working. Now, what the fast API layer did, first thing it created, it called this fast API class from the fast API module, created an object of that. And now it's a simple method. Using that fast API object, you have created a post endpoint, which internally, okay, is calling your greet logic tool. And this greet request is just for identity validation. Okay. So yeah, this was how it all works concept wise. Okay. Okay. So I have second, for the second part of demo, we will see how we can expose vector databases as the tools, because see, this was a very simple server with one tool, and in this case we wrote the tool itself in the same script. So you had both a fast API and fast MCP server and fast API server in the same script, okay, to keep it simple. But it won't be this simple always, right? Normally when you work with a database, you would have some basic operations possible, right? CRUD, for example, you should be able to create something, read something, update something, or delete something. So what we will do is we will activate one MCP client, let's say for Milvus, okay? Or maybe let's, before activating, ask it whether it has access to those tools. So do you have access to MCP? So Milvus is a vector database. Milvus. It does not have access. But now let me just enable this server. Same question I will ask again. See, it has access now. Now we can ask it to do things for us. Can you list all collections in the vector database for me? Again, since it's running a tool, it seeks permission first. Okay, so there is one collection there. Can you show me the contents? I'm intentionally not giving too many details because it is able to make sense of the previous chat history as well. Everything is being sent as context. Okay, so there is, it's empty. Okay, now let's try one more. So do you, again, see, basically if you can list something from a database, you can do the other operations as well. The server is working. Do you have, so there is another vector database called ChromaDB. So let's see if it has access to that. Do you have access to ChromaDB tools? Again, it says no. Let me go and activate it. Same question I will ask again. Okay, so it has access. So if you really think about it, in the drop down, you are selecting only one agent. So what that means is this is one single LLM powering this single agent architecture, and your agent has access to multiple tools, and the upper bound for that is 128 tools. Okay, so which let me show you the error so that you are sure. Let me enable everything. Okay, now if I ask it something, even high, it will say sorry because I have included more than 128 tools, which confuses the agent. Okay. Okay. So this is all about the agent mode in VS Code. Now let me show you some cool things. See, apart from using the paid models, we also have an option to run the models locally and integrate it in the agent mode. So for example, let me integrate this local Pi 4 model, which will run using Olama. Okay. Let me deactivate the unnecessary tools. Now let me just say hi again. So this is a local model. Of course, it will not be as good as the Copilot models. Okay, fine. It's at least working. Okay. So in VS Code, you also have an option to look at the models which you have available in your local. It provides you an easy way to interact with those models. Okay. So let's wait for it to refresh. This is no longer needed. Okay, so in my local, see, this is one of the most recent SLMs which has been released by Google. It's Gemma 3N. It's just 1 billion parameters. Okay, and this is, I think it's less than 1 billion actually. It's N. So this is supposed to run on your mobile phone, tablet, everything. It's so small, this one. And they even have quantized versions of these models available. Quantization is more like if you have stored something in FP floating point 16 precision and you reduce that to FP8. So of course the number of bits used to store that parameter value will reduce, and that will reduce your overall size. So, okay, let's just test it once. It's running locally. Okay, here I can see what all I have. Okay, so even in local, you can run text-only LLMs. Again, when working with LLMs, you have to remember that the modalities can be different, both for input and output. It's possible that your model only accepts text as an input and gives text as an output. In some cases, it can even, most of the recent LLMs allow you to even provide an image as a context, but that need not be the case with all the small language models. But this Quen 2.5 VL, this is a recent 2 billion parameter model which has option to even provide an image as an input. For example, if I provided an image, and again this is running locally for free. What is this? Okay, so I asked this model. Okay, this is a very small model, so it it says it's an insect. Let's change the model. Choose a good one. We'll ask the same question. So while this is running, the important thing to remember is not all models are equally good. Sometimes smaller models might not be useful for some particular use case. So the choice of models and the number of, again, choosing which variant of that model, 1 billion, 2 billion, depending upon what versions available, depends on the use case. So first we should be able to play around with them like this to evaluate them. Then we can take a call. There is no right model for everything. Okay. And advantage is if you are using SLMs, self-hosted SLMs, there won't be any per token charge, which is a good thing. Okay. So now, normally, see, if you have to keep an eye on the cool model, so what I do is I keep an eye on the major providers, like for example, OpenAI, right? So for most enterprise use cases, you would see people using this. So on their official site, we can see for reasoning what all models they have, for chat what all models they have. So you see audio. This has audio also as one of the input and output modalities. And what is cheaper according to them? Deep research, very costly. Real time, so they can stream real time both text and audio. Image generation, text to speech transcription, embedding models. Okay, one way is you go to their official websites and see what is there. Gemini, Gemma, both from Google. So this is Gemini is closed model. This Gemma is open model. Same for Llama. Okay, so but keeping an eye on all the websites or providers is exhausting. So an easy way is to look for something like this. So Google has a model garden, okay, which makes it slightly easier to look for models as per your use case. So for example, if my use case is text generation, I can see what are their recommendations, okay, and what are the open models available, what are the models I can fine tune, and in general, what is the newest. I told you Gemma 3n is the newest. So it helps because things change too fast and we can't keep checking all the websites. So even you ask something like chat gpt what is the latest model, most of the times they won't know about the latest models. Okay, just like this, even Azure has something called Azure AI Foundry. Again, they have a different kind of leaderboards there. So I like these two websites. Okay, but again, all most of these are paid in some way. But if you want to run everything locally for experiments, Olama is a good option. So the model which I showed you towards the Indian VS Code, they all were run using Olama, and it's very simple. All you have to do is just run this, install Olama and just run this. It will download that model for you. And so Gemma 3n is also available now. It's not yet updated here. Yeah. In order to keep know what is the latest, you need to check the library for Olama. Here you can find what's the latest one, Gemma 3n. See, already 74,000 people have pulled it in just 1 week. Okay. Another tool I like is Notebook LM. So here you can ingest books. It creates a mind map for you. It can create an audio overview. It's like a two people podcast, which you can simply listen in cab and all. And so yeah, I think this is all I had. I will stop sharing now.
Thank you, sir.
If any questions, you can take now.
Yeah, we can have a 5 minutes Q&A session. I request all the students to complete the poll, feedback poll. It is available in the chat. You can
Okay.
you can unmute yourself right now if you have any questions.
Okay. I see there are questions in the chat.
Yes, in the chat also. Yes, sir. Yes.
Let me look at them one by one. Okay.
Sure.
First one, is there any LLM service providing an API that we can fine tune by image and use for our specific use case, like image to image generating model? Image to image. Yes, there are models that are available there. I have specifically not worked on this kind of model. Okay, there's some echo from somebody. Yeah, but definitely there are models. Okay, so most of the work I have done is mostly on the advanced RAG. So that's the text models, which can take image as an input modality, but not necessarily generate it. But there are definitely models which can do this as well, and we can fine tune them. So a good use case for this kind of models, which I have seen, is, let's say there is some company, right, and they have some mascot. It could be, let's say, a bunny, right? Now in all their advertisements, they want to create some logo. So what they would do is they will fine tune this kind of model to generate images of that mascot in different situations. It could be eating some biscuit or some tea. Okay, so this does exist, this kind of models. Okay, you can check in the model zoo actually. Oh, sorry, not model zoo, model garden. Let me paste these two links in the chat. 1 second. But it, like, these models exist and a lot of commercial application as well. And the third thing, I think this Olama library also, I think everyone should know actually. Okay, let me go to the second question. I notice sometimes when I ask something to chat GPT, it starts search on the web. On that time, it is also doing RAG, similarity search, vector database, rank and curate chunks, or it's something different. No. So see, when it is doing the web search, right, it is calling a tool, web search tool. So it's not looking for that information in the database. It is actually doing a web search for you. And whatever information is returned by that, that will be processed and made available as is in the context that is passed on to the LLM. So it looks kind of similar, but this is different. It's a tool that it is calling. Okay, not RAG. So how does
Sorry
the
for inter.
yes,
Actually, you said that there is an image generation model, right? Yeah, they provide like GPT image one or image 3, and in the uh, model garden, right? Is there a
yes,
model like we can fine tune and make images by training with our images and providing to learn the patterns and all, and providing an output as we expected, or all images, all generative image generation is like hallucinated, right? Nowadays.
no, there are, that's what there are models. Okay, I have not worked on that use case, but I have seen some folks in my organization. So
Oh,
it's like you have some set of images, right, and then you fine tune
yeah.
this model, and then you can ask the model to generate similar images in different situations.
Ah, okay.
Okay, so models are
Uh,
definitely there. It's just that I don't know the name of those models, but definitely there are.
okay, okay. I will research it, no problem. If you
Okay,
have any, sir. Okay, okay. Thank you, sir. Yes,
okay, so I will move on to the next one. How does the agent decide what tool to use? Okay, so see, now agent is essentially a wrapper on top of your LLM. Okay, when you ask LLM something, it is able to do it, right? Now, what you do is you provide that LLM all the information about the tools, their capabilities, and a nice description. So it is like asking a question where you are giving the LLM 20 options. Okay, you're asking, okay, this is my questions. Do you think any of these tools will be helpful? So the LLM will decide actually. So the LLM that is powering the agent, that decides which tool to use, and not just that. When calling that tool, what arguments need to be passed, that is also decided by the LLM, and the agent passes it to the actual tool, runs it, and sends back the response generated back to the LLM to see if that is enough or if some other tools are required to be called. So Agent, you can think of it, a single agent. In a single agent architecture, there is an LLM. On top of it, you have a simple wrapper which allows you to persist your memory. Like that is all the past interactions. Keep a check on the set of tools that are available so that it all is available to the powering underlying LLM to make the right calls. Okay. Why is it called OpenAI if it is not open source? So originally they were non-profit organization when they came up with this name OpenAI, but later once they realized like it's quite profitable, they decided to not open sources. The original GPT model, the initial version, that was open source. A lot of people still use it for understanding the underlying architecture, but the newer models, they all are closed source. Starting GPT 3.5, which powered the Chat GPT UI, it's all closed source now. Okay. Yeah, I think somebody wrote it. It was initially yes. So why is he not mentioning DeepSeek? Okay. Again, since it's from China, right? And a lot of companies are hesitant to be honest. And we don't use it. That's why I did not mention DeepSeek. But yeah, it is one of again, it was also popular recently, but because of its origin, it's not that used in enterprise use cases. Is there any free model API sources? Yes. So the quickest way would be Gemini AI Studio. Okay, there you can get an API key and you can access the Gemini models. There will be, of course, some limit. Okay, let me just paste that link of Gemini AI Studio. So this Olama models, which I was running locally, right? Even that, when you run it locally, you get an endpoint actually, an actual API endpoint which you can use for development. So one second. But this Google AI Studio is easy to start with. Let me go to the next one. Okay, next is, can you send feedback again? Okay. While running model locally, what kind of graphic card or configuration is required? Okay, so let me share my screen for this. One second. Okay, so if you are planning to start with Olama, it is comparatively easier. Okay, I would suggest starting with, I think you all should have Olama on your laptops, and just start with Gemma 3N. Okay, see, if you think Gemma 3 itself requires just 815 MB of RAM, no GPU required. Okay, for this one. Now we even have Gemma 3N. If you go to the library, command are very simple, right? Olama run that model name. Okay, so Gemma 3N, let's see how much memory it needs. Okay, size, view all. Okay, so this is actually slightly bigger than I thought of it. So in that case, I would suggest starting with Gemma 3 only, because if you see the smallest model, right, it requires just 815 MB. So start with this, I think, and then slowly you can move up. And for if you need a multimodal model which can understand images, I will suggest Qwen. This one, Qwen 2.5 VL, the 3 billion version of it. It is, again, it can run on your local, and you can create applications where even input images are possible as context. Okay. Let me stop sharing again. So yeah, okay, this is done. Feedback. Okay, this is done. So yeah, and for like see for the high end model, definitely you need graphic card, and the kind of graphic card, again, see, as a student or as a developer, it's not like I will buy a specific graphic card. Mostly, it's like you can use some decent graphic card possible. The model, see, most of these do require Tesla. I think it's T4 on Colab, right? So that one is good actually, but again, it's not something we all will go and purchase. So I would suggest, like as students, you should start with Olama, so that you can have as many models available for experimentation for your projects. Apart from that, Gemini AI Studio can give you APIs. And as students, I remember at Amrita, I got Azure credits, $100 per year, I think. So using that, you can use Azure OpenAI to create some model deployment that will give you an API key using which you can use OpenAI models. So you can try that. See, most of these cloud providers have some credits for students. So see, Google has Vertex AI, AWS has Bedrock, Azure has Azure OpenAI. Okay, so they are like a superset of providers. If you go there, you can get access to most of the providers through that cloud itself. Okay, so that's why see, I primarily work on Azure and AWS, but for LLMs, I even use GCP's Vertex AI. Okay, and again, cloud was part of my curriculum, so cloud is very helpful. You need to know it. It's like no brainer. Okay, let me go to. I have TI. I did not have a good experience. I think the recent line was. I think you try Olama. Okay, or quantize models at least. That should be fine locally. Okay. Okay, thanks for this good feedback. I will give a heart. For generative AI, which language model would be good and the hardware requirements? Again, start with Olama. Even your current laptop might be enough. Okay, for text-only LLMs, the smaller ones, and in some cases, even quantized versions are available. So you can try that. Start with, I would not suggest go to the shop and buy a new laptop. Try with your existing laptops. Most of these models, smaller ones, will work, and if they don't work, go for the free APIs. Okay. Fine tuning, even for fine tuning, see this Gemma 3N, it can be fine tuned on what you have available on Google Colab. Okay. So try to make use of those GPUs. And see, a lot of hackathons are happening these days, where people use collabs even to do well. So GPU is not a blocker actually to learn this. Okay, I'm working on a project related to RAG, how to evaluate the RAG performance and accuracy. Okay, see, this is one tricky area where a lot of existing solutions don't work that well. Ragas is a popular library to evaluate RAG. Okay, but again, in RAG, you have to do evaluation at two steps. When you actually retrieve those chunks, you need to check whether those chunks are relevant to your actual query, right? So even for retrieval, you have some metrics available in Ragas. And then once the final response is generated, you need to have evals for the generation. So in again, now for retrieval and generation, you can start with Ragas, but in most cases, you would see that like some of these things, right, it's good to start manually first, just to see how good is the retrieval, how good is the response, and then you can go with some tool or SDK to do it and see what other options are there. But Ragas is the most popular one. Okay, so Ragas is an SDK, so it's free to use. Free Ovid Pro. Okay. Okay, now we are moving toward quantum computer as it has random state. Will it going to merge with ML? Yeah, you know there is something called quantum machine learning also. At this point, I have not seen anyone using quantum computers for generative AI. I'm not keeping an eye on that much on quantum computing, but it was part of my MTech curriculum, so that much I remember. But yeah, even our subject was called quantum machine learning, quantum artificial intelligence, I think. So it's there, it's already there actually. There are machine learning models that use quantum computers. You can check it out. It won't merge definitely because they will not be that cheap anytime in near future. So right now, the push is towards small language models, which can even run on mobile phones, right? So Google has an Android application called AI Edge Library, using which you can run some of these models on your mobile phone actually, the quantized ones. So that is not available on Play Store. You have to actually go to GitHub and download that APK. So I have actually a spare phone, so I'm trying on it. Uh, but yeah, I think the move will be first towards running these models on cheaper hardware so that privacy concerns are not there. This notebook LM, right? For example, people will be able to run stuff like this on their mobile phones, where you index everything locally, it's on your mobile phone, not going to cloud. It's possible. So there is a 1 bit, yes. So this was also there. I would not say it's completely stripped down. It's more of it's quantization. It's quantized to that. Whatever, it will still have the same number of parameters. Is that just that the value of that parameter will be stored in on 1 bit instead of let's say 8 bits or 16 bits. So again, all this pushes towards making it run on cheaper hardware. So I won't say stripped down. It's quantized version of it. Again, it might not be useful for all the use cases, but such models can still do something like classification, right? If you run it locally and ask it to classify, let's say, some document into your folders on your mobile phone. So the moment you download something, it should at least be able to classify it, if not summarize it that well. So now WhatsApp is coming with a new feature where they want to summarize all the 100 messages in a group, which can be a problem, right? Sometimes if you don't open a group, there can be 500 messages. Now if you read them one by one, it takes time. So WhatsApp is coming with a feature where they will summarize it. So for such use cases, one way is they summarize it over the cloud again, but they say, right, it's encrypted, so that's not a good idea. But imagine if there's a 1 bit LLM running locally on your mobile phone. They could instead run that as part of their application and summarize it locally. That will be more privacy, uh, I think, privacy oriented solution. So okay, so for career in AI, see, definitely at the moment, a lot of things are changing too fast, and it's a little crazy out there. And for example, even in large language models, right, you have text-only LLMs, you have multimodal LLMs, you have text-only embeddings, then you have multimodal embeddings, which can embed both text and image data in the same embedding space. And then you have something called sparse embeddings. So like, it's very interesting field, but I think as a student, if I would have done it again, I would have still focused on my subjects for sure. Stronghold on the basics will still differentiate folks. Apart from that, if you get a chance to do any project, try to do it end to end. Don't just run it in a notebook. Try to actually see if you can quantize it, if you can deploy it somewhere, if you can expose it as an API and host it on some cloud so that you can demo it to your classmates during presentations via the deployed URL. So it's possible actually. In my MTech, I was able to use some free credits to deploy Streamlit kind of applications. So there was so it's possible, it helps. I had put that on my GitHub also. It's pinned. Okay, there is Google CLI tool also with. Yeah, this is a new one. Okay, what they have done is now so far we were used to interacting with LLMs through chat, right? Now what they have done is in the command line itself you have AI. So now instead of saying kubectl, you can say list all the pods in this namespace on this cluster. So the AI will convert that message to actual Kubernetes command and run it for you. So it's cool actually. Again, but the problem is if you start using it too much also, right? In an interview, they will like ask you that command. Still, they will ask you that command. So it's good to know as student, but you should also do it manually. See, I wrote that code for you guys just to showcase the power of agent mode. But if you ask me if I'm writing my code in Office like that, no. It's just I use it as a productivity tool, not as my own alternative, right? So, and I was still able to understand that code because I can write it the other way also. So that way, if imagine if somebody is writing from the beginning like this, and an actual issue happens, they won't be able to figure it out actually. And LLMs fail. Okay, LLMs also fail while solving actual issues in projects. I like in the last 1 month, I would have fixed 10 issues where LLMs were not helpful at all. So be careful, like learn your subjects well, but do projects which replicate the real project scenarios. End to end is the best way. Code should be on GitHub. In the README, there should be URL of the deployed service so that anyone who goes to your repo can actually click it, see that UI, try what you did. So that shows you know it end to end. And if you don't get a Kubernetes cluster for testing on some cloud, you can run Minikube, have a local Kubernetes cluster for testing before you actually deploy it somewhere.
Ashaya, Narendra. This is Vidya Lakshmi.
Hi, Vidya.
Hi. So it was really nice hearing from you. It was
Yeah,
really wonderful, and thank you so much for the willingness. Immediately, quickly, when we asked your help, you came here. It was really wonderful. Our students are having a lot of doubts regarding all of this. I think
I'm happy to
you'll be
see
aware.
more questions. Yeah,
Yeah. It's really wonderful. Thank you. Thank you so much, Narendra, for your willingness. Out of your busy schedule, you find out some time to share with our students. It's really wonderful. Thank you.
thanks, Vidya. I see two more questions. Maybe I will answer that.
Yeah.
Okay. Is there any alternative for Olama because faced Olama issue like indexes, FIS? Yeah, I think you can use Gemini AI Studio. Okay. FIS is again a light. It's not a vector DB. It's a library which we use for indexing. So you can use Gemini AI Studio to get a Gemini API key. Okay. Can you quickly share key difference between data scientist versus ML engineer versus AI engineer versus Gen AI engineer? Okay. So in most companies, the boundary is very blurred. Okay. I was a data scientist at L&T, but I never did like the data science where people are drawing inferences and all. I was mostly working on computer vision and deployments. So the designations can be very misleading. But if you ask me, data scientist is supposed to be working more on things like demand forecasting. ML engineer is supposed to be working more on things related to deploying those models created by data scientists. AI engineer is supposed to use everything to improve any existing process. It could be automatic triaging of Jira tickets created by some client. And Gen AI engineer, I think nowadays most of us are working on Gen AI. So we are using LLMs, creating wrappers on top of it. Um, and this whole scalable pipeline, I think 80% of the time goes in pipeline actually for Gen AI because the smartness is already there, but creating a scalable solution out of it, which actually serves your purpose, it's very interesting because the tools and all, right? This MCP server and all these things. So a lot of work is there. Which is the most effective chunking strategy of handling both text and table content in RAG application? I think you can try, again, see, now table for table content, first thing is how you are parsing it, right? We have doclink, for example, quite popular. IPDF is there. And, If you are able to extract the table content well, and that after that you can try with recursive first, and then agentic chunking you can define using an LLM if your results are not good. But again, it's not. I think if the extraction is good, most of the chunking strategy should work well actually. The main challenge I see is extracting the information from the document, because the formats can get very typical. But if you are using something like LangChain, you can give it a try. I think 3 or 4 chunking strategies are available there. See, there is nothing more or less effective. It depends on the use case, what works for you. Okay. Sir, why AI is considered as artificial intelligence? Isn't it wrong, since AI isn't really machine learning where we have given? It is learning, right? The LLM is trained on a lot of underlying data where it saw the examples and figured out the patterns. So yeah, it is machine learning actually. Sir, if you want to integrate a voice bot with the agent, what will be a sample workflow assuming and okay, speech. Okay, this last use case, okay, this is very interesting. And now a lot of people are coming up with open source models even for this. Okay, at the moment it's not that easy to do it. Because see, voice mode, right, in LLMs, now you're able to talk to LLMs, and the LLMs are able to give you response in a real voice. So most of that is not open source, and whatever is open source is not that good actually. But recently I see even chat GPTs, right, web UI has a audio mode now, and I bookmarked something actually uh, where there is some team which is working on this, what you posted actually. So they are coming up with a open source framework to convert text to voice and vice versa. So I have bookmarked it. uh, I, say hi to me on LinkedIn, I will send it to you. Okay, it's somewhere. I have bookmarked a post on LinkedIn about this. Yeah, of course there should be a WhatsApp group actually. We had one, you I should also have one. Okay, GANs I have not worked. Okay, I studied it in MTech, but after that I never had to interact with GANs directly. You can search Naren Singh Bish, Amrita Vishwadyapitam. You will get it, but I can still share it. Yeah, but in this field, like I still have to study a lot. Okay, to be very honest, if I don't study, it's very hard actually. Okay, I think that's all. Vidya, you are still there?
No, sir.
Okay.
So she's having another orientation session
Okay.
with the new batch of students. So she just left.
Okay, I think I'm done then. Answered all the questions.
Thank you so much, sir, for your wonderful session. I hope all the students are, so many students were looking forward to this webinar since a week, since we announced this session. So we are so happy that it went very well. And I thank on behalf of the department for taking up the session and giving us true insight on the topic. Thank you so much, sir.
Luckily, everything worked. In demo,
Yes.
sometimes things don't work.